Welcome everyone, and thank you for coming to this session on how elevating SQL Server performance using query store ints that are a little feature that came recently on the newest SQL Server version, and I think it might be very useful for you. My name is Rui Carvalho. I work as a data engineer at DevScope. It's a company based in Portugal. We work with BI and data mainly. I work with data for more than 6 years now. I started on a more analytics side, and I've been migrating over the years for an engineering role. I'm also a Medium writer. I write on Medium on a weekly basis on all the subjects around data, mainly on Microsoft features like Fabric, Power BI, Databricks also, and other things on the data engineering world. I began my speaker journey a year ago, also on SQL Bits, and it's been a pleasure and a good journey so far to be a presenter and to be able to share knowledge with people like you. So for the ones who are not very used on what is the query store, let's first land on some I will give you some details on what is the query store and why it's so important. So basically the query store acts as a repository on your SQL Server database, and it's designed to store the history of the execution plans for each query that runs on the engine. One of the most important capabilities is the ability to force and unforce the desired execution plans that you want for a specific query. So imagine that a query has an execution plan, and someone in the time the execution plan changes. You can take a look at why, and probably you may want to force an older execution plan because it was better. So you can do stuff like that. It captures the detailed performance over the time that query runs. This is not includes not just which queries were run, so you can also have access how they perform in the engine. And it also provides some detailed control on what query captures, so you basically can focus on the queries that are most critical to your application performance. Okay. One more thing, you are saving this history on the query store. You don't need to worry to lose it. So even if after server restarts or even upgrades, you will keep all the history of your query execution plans. So now, what is a SQL Server int? Basically, ints are instructions that are sent to the SQL Server optimizer that will affect the execution plan selected for a particular query. They are used to adjust the query execution when basically the optimizer is unable to produce the most efficient plan. Some examples of that are, for example, the max DOP, which basically limits the number of processor cores that a query uses. For example, the no lock for reducing the locking contention, recompile to regenerate a new execution plan after a query execution, and there's a lot more ints of this kind that basically change the query behavior at your own needs, even if it's to get a better performance or just to get a better application behavior. In this example, in this query, I'm applying an int that is a max DOP. I'm specifying a max DOP tool that basically I'm limiting the number of processor cores used to execute this query. So it's this kind of behavior that we change when we are using an int. Why do we need to change the query behavior? So ideally, the engine should choose the best execution strategy. It's intended to function that way, but it doesn't always do so. So in these situations, a DBA or someone that is looking for a way to improve the performance might want to optimize the query to get a different execution. Otherwise, we basically are left with poor plans, and with that, we are getting worse performance, right? So some reasons for that are basically these two that I said. Even if we are relying on the engine to pick us the best execution plan, it doesn't always succeed. So we need to take care of that. We need some intervention of our own. we want to avoid inefficient query plans, so we don't have a degraded performance on our application. Also, situations like stored procedures that are highly variable, that has a higher availability, selectivity while using parameters, we may need to use ints to, for example, a recompile int to regenerate execution plans for its execution to ensure the optimal execution of that. Memory grant size limitation, so make sure we take care of memory contention while running expensive queries. And also, for example, adjusting the parallelism, the example that I did, if you want to adjust the max degree of parallelism of your queries, that's also a way that you can do it. So you don't have expensive queries consuming a lot of processor alongside other important application procedures. And basically we arrive at the query store int. The query store int is an extension of the query store. It arrived on and is only available on SQL Server 2022. And basically what you do here is, without changing the original query text, that's what I did before, you can add a query level int to the execution plan produced in the SQL Server on the query store level. Basically, imagine if you have that specific query you executed on your application code. You don't need to go to the application code and change the code directly. Even if you have that specific query specified multiple times on your code, you don't need to go to each one to change that code. You just need to set on the query store level that specific int that you want to apply on the query, and you are good to go. In the next execution of that specific query, it will use the int that you specified. So imagine like a metadata table for your ints and queries. Okay, so how all this works. Basically, the first step that needs to happen is a query needs to be executed. And if you have the query store activated on your database, the query will be captured on the query store. After that, a DBA or someone that wants to create a query int and change the behavior of that specific query can create a query store int on the query store level. And like I said, in the next execution, that query will use the int for that execution. So let's focus now on that third step where the query store int happens. Let's see how we can do this. So the first thing that you may need to do is to run a query like this that will give you this information that is all the queries that are captured on your query store. For the query store int purpose, the only thing that we need is the query ID. Okay, so what we have now is we have available with the query store int some stored procedures. This one, for example, is the one that you will execute to set the specific int that you want. So all you need is to use the query ID as a parameter and also the value that will represent the int that you want to apply. In this case, I'm applying a max.1 on the query ID 512. After that, you can check for all the ints that you have. In this case, we have applied the int to that query. And if you don't need the query anymore for future executions, you can just run another stored procedure that is available to query to clear that int from your engine. Okay. So I will show you now a demo where I will show you two situations where you can apply this. So the first thing that you need to assure is to have the query store activated. You just need to go to the properties of your database. Remember, SQL Server 2022 has it available by default, but even if that, you can check for operation mode in the query store settings to be read and write, and you are good to go. So, like I've shown you, you have a query like this that you may need to run to find all the queries that are stored on the query store level. Okay. In this case, I just want to get the query text and the query ID. That's the only thing I need for setting a int. Okay. So just to start fresh, I will just clear my query store. And if I run this query, currently I will have nothing stored. So let's get ahead for the first example. In this case, I have a big query. I'm using some group bys, order bys. I'm doing some inner joins with complex tables. I'm going to execute this query. I will include the actual execution plan, and I want you to see the execution plan after this query execution. So let's take a look. In this example, as you can see, we have several activities, several parallelism activities, okay? So basically, we are using multiple processor cores to execute this query, and this is fine, because it's probably the best way to execute this, and the engine understood that way. But imagine if we are running queries like this alongside other critical application runs, and we don't want to be using a lot of parallelism here because this query is not actually so important, so we don't need that. And we don't want to impact the other queries. One thing you can do is to set the int on the query, and in this case, I'm setting a max degree of parallelism. That in this case, I will limit the parallelism to 1, which is no parallelism at all. If you check again the execution plan, I no longer have parallelism activities. So this is a simple example. One thing that we can do now, we did this. We basically changed the code. So what I want to do now, I don't want to do that manually. I want to go to the query store level and set this int. So let's take a look at our query store queries, running the same query again. And now I have the information of these two queries that I've just run. They are similar but different because one uses the int and the other don't. So the first row is the query that uses the int. I want the other one, the first query that we executed, that has the ID number 2. Okay. So the only thing that we need to get from here is the query ID, and now we have that specific stored procedure, okay, that we are going to run. It's called sp query store int. We are going to use the query ID and the value that will, like I said, represent the int that you want to apply on this query. So for these situations, I will set the int for the query ID 2, and the int will be the max.1. So after I run this, everything is set, and I can check in this table. That's also a table available for the query store ints that is called query store query ints. If I run this, I will have available all the query ints set on query store. So like you see, this is the int that we have just applied. It's basically like a metadata table where you don't need to spread all the ints along your code. You can just do it here. It's very much clean compared to that. Okay. So let's execute the same query, this time without the int. And if we see the execution plan, we are supposed to not have the parallelism activities anymore. Okay, even if this query is spread around our code, every time this query is executed, it will use the int that we specified one time. Okay, so let's see a second demo, and this is where actually you can improve the performance. So we have these two queries that are actually the same but with different product IDs. One of them is the 897 product ID. The other one runs the where clause as the 870 product ID. Okay, try to remember these IDs because it's important. So let's run these two queries alongside. Let's check the execution plan for both. As you can see, the first query has a better execution plan than the other one, even if they are the same query. That's just because the first query, the first product ID only filters to registers, and the engine understands that this is a better execution plan for that run. Okay, compared to the other one that I believe it has 4,000 rows for that product ID. This is not a problem so far. So the engine is deciding the best execution plan for each query. But the problems might start to appear when we are using a query like this with a filter like this in a stored procedure. So in this case, I will create a stored procedure with this query with the product ID as a parameter. And after that, we will run the stored procedure for the same two product IDs, and we will check again the execution plan. I will run the first execution for the product ID 870 that, remember, was the one with the worst plan between the two. Let's execute this. Let's check for the execution plan. So it's basically the same as before. Okay, no problem so far. And if you run again the stored procedure for the other product ID, 897, that was the one with the good execution plan, but this time it's using the same. That's basically the stored procedure kept the engine kept the first execution plan from the first execution to be used for the next executions. This is using to recycle these execution plans, but sometimes it happens situations like this that are called the parameter sniffing. One thing that we can do to avoid this is using a recompile int that basically for each execution of this query, it will regenerate a new execution plan for this execution. That's basically what we want. So let's do the same thing. Let's go for the query store level check for our procedure execution. That's the first row. Okay. And let's do the same process. Let's get the query ID. In this case, it's the query ID 8. And let's run the stored procedure for that query ID. Okay. In this case, I want to set in the value, I want to set a recompile int. So basically, let's check again if we have everything set on our query store query ints table. Everything good. So we have these two query ints created so far. So now let's execute again the same stored procedure without changing anything on it, and let's compare again the execution plans. So we run the first one. We already know what the execution plan is. Okay, so same thing. Nothing changes here, but if you run again the product ID 897, now the execution plan is the one as before, which is a better plan for this specific product ID execution. So in this way, it's another way that you can actually, without changing all your application code, just set the query store int to avoid the behavior that you had before. And of course, situations like this, like parameter sniff, can be avoidable with this kind of treatment. Okay. One more thing that you can do, basically, if you don't want these ints anymore, it's better to clean it. So you can just run another stored procedure called query store clear ints. Just need to go for a query ID, need to set the query ID. In this case, will be the 2 and 8, and we are able to clean it. Check again, and everything is clean. So some important notes on the query store ints. So basically, you can write one more than one int for a specific query by passing a string with all the ints that you want to apply. All the ints applied are persisted after system restarts, so same thing as query store. Query store ints take precedence as the hard-coded statement level int. So if you have an int on your code and an int on the query store int will take precedence on that. And also, if you specify an impossible action on the query store, the engine will understand it and will avoid it, ignoring the int, and execute the query normally. Okay. So some benefits that we can take from it. We can have a detailed influence on how SQL Server executes the query, ensuring a better performance and achieving different behaviors. We can apply ints on the query, directly on the query store level, avoiding modifications on all your application code. And also, this approach will allow us to address performance issues in a more effective way, since we don't have the time cost on our database for all the queries that are getting issues. So some reference here just to finish. I have an article on that on my Medium that you can check out. Thank you very much, everyone. Feel free, we are on time, feel free to approach me for any question that you may have. You can scan this QR code for my socials and also to give feedback on this session. Thank you very much.